Hi everybody, welcome back. Today we'll be going through the explanation of the Diffie-Helman key exchange. Okay, let's do a quick review. First we talked about the fundamental theory of arithmetic and how every single number has a unique prime factorization, which can be used as a key combination. Then we talked about the Cold War and the need for two parties to be able to agree on a shared key while never meeting each other and through an insecure channel. So in our example, Kim was eavesdropping and making this insecure. Then this is getting pretty annoying. Okay, get rid of that. Then we talked about a one-way function. We introduced this concept by using paints, and we said it was easy to mix colors to get purple, but it's very hard to reverse it. It's very hard to figure out what colors made up this purple. Then we introduced numbers because this is actually what the Diffie-Helman key exchange protocol actually uses. So we talked about the discrete logarithmic problem and how calculating 3 to the 29 mod 17, it's easy to figure out that that's congruent to 12. But given that it's congruent to 12, it's pretty hard to figure out what this exponent is. Lastly, we talked about the strength of a one-way function and how it is calculated by the time it takes to reverse it. So if we had a prime modulus with hundreds of numbers, then it would take even very fast computers thousands of years to calculate this. Great. Now let's actually get to the explanation. And I hope I'll have enough time. So we'll redraw our channel, and we have Kim right here being nosy. We have Jan, and we have Bob. First, Bob and Jan are going to agree publicly on a prime modulus, for sure, I'll say PM, that is prime modulus, and a generator. Okay, and in the previous lectures, we used something like this, right? So our prime modulus is going to be 17, and our generator is going to be 3. Great. Next, both Bob and Jan are going to select a private random number. Okay, so we'll say for Bob, it's going to be, let's say 15. And for Jan, it's going to be 13. Okay? Next, Bob and Jan are going to share, they're going to take the generator, they're going to raise it by their private random number, and they're going to calculate what that is. Okay? I think this should be 6. And Jan will do something similar. She'll take hers. Whoops. And I think this should be 12. Okay. So let's make this orange. Okay. Now they're going to exchange what their results were, their public results, okay? So Bob is going to give Jan his 6, and Jan is going to give Bob her 12. And Kim is getting both of these because she is eavesdropping. Great. Now we have the heart of the trick. This is where things get exciting. Okay, so Bob is going to take his public result, which was 12, and he's going to raise it to the power of his private number, which was 15. And he's going to compute the result of that, and he will get 10. Jan is going to do something similar. She's going to take her public result, which was 6. She's going to raise it to her private number. And I'm sorry about that. This should be mod 17. And she's going to get, are you ready for this? 10. And now we have our shared key. It looks like I'm running out of time, so please join me in the next lecture. Thanks.